Okay, so I wanted to ask a quick little question um, about physics. So we're going to start with the box. Okay, let's turn off the gravity and the wind. All right, create a box. No big deal. Okay, boom. That's simple. I don't think anybody argues that this is what it is. Glue together. Okay, so let's do a quick couple of experiments just to show you what I'm thinking here. So boom, 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 boom. Grab that, pull this back. Oh, okay, put a ball there. Okay, so everybody agrees. Get rid of this nonsense right now. I press play. That ball is going to be shot this way, but this thing's never going to go out of its position, right? So let's go faster. It's just going to shake back and forth, not really going anywhere. It could spin around, I mean, theoretically. But for the most part, it's not going to go anywhere. You can't really knock yourself out of your your orbit or whatever, your center of mass like that. And everybody's in agreement with that. So all you're going to do is just shake back and forth, not doing anything for pretty much ever and ever and ever. Let's see. Yeah. So no. Okay. So yeah. All right. So everybody's cool with that. It's not going to go anywhere, and I'm not saying it would. All right. So you hit that, boom, goes nowhere. Right now you're just stopped. Look, there's no movement at all. You're going nowhere. That movement caused. Actually, you did move. Let's go back a little bit. If I go in real close, you'll notice this outer frame shifts with this inner frame. Watch. See? Little tiny shift. No big deal. Right? Shift, 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 shift. Not magic. Okay. So, that physics is fine. It works good. I could take this thing and just make sure that this works. Okay, so we're floating around out in space. That thing flies away. Get rid of this. Okay. So now we know we could fly something into. Oh, wait, no. Okay. Let's stop this. Okay, so I take this thingamajiggy and I put a rocket, no, on here. Okay, and then I tell the rocket that I want to give it a lot of thrust and only when I hit the one button. So I hit the one button, that's going to go. Right now I do nothing, nothing's going to move. Right, so I hit this. Oh, yeah, that's going really fast. Let's go really slow. All right, so boom. I hit this. Oh, okay, so I put the rocket thruster on way too hard. And that's way too light a thing. So there we go. So you can see, put the rocket thruster on. It's not really in the right position, but it's going to go through and it's going to smack that thing. Okay, so good. Good. Let's bring it up to 1. We figured out how not to just destroy everything. Okay, and boom. Right? That's fine. Nobody has any problem with that. Right? Because that's going to go one way, that's going to go another, and we know that this system here, oop, now it's definitely going to go. But this system here, right, this, box, with the spring on it, actually, let me get rid of the spring. We don't need the spring. Oop, we need the box. Okay, so, oh yes, okay. So we know that the box, we hit this, everything stopped. I hit 1, right? It's eventually going to crack into this thing no matter what I do. Boom, right? Oof. Now they both move, but this one going to go that way forever, right? And this one is going to go this way forever. Make sense? Okay. So now Let's try something else. So we got this really long spaceship, right? And it's just a big long tunnel. What if we did this? Okay, you see what I'm saying? So I take this and I put this here. Okay. So I know this is 2D, it's not 3D or anything else like that, but the problem is the explosion and the gases that are going to explode out of here aren't really going to hit down here quite the same way. We're not expelling mass. I don't know what's going to happen. I mean, think about it. Like, okay, so, and again, we can say that this is a toy system, but let's look at the physics. So what's about to happen here? A few momentums. All right, let's just give it a little shot and see what happens. So I'm going to hit 1. Okay. And now while this thing is in flight, I'm going to press it again. Boom. Now it's still in flight. I'm going to press it again. Boom. It's still in flight. Boom. Okay. So yeah, I'm expelling mass, right? But I'm not really getting rid of my projectile. You get what I'm saying? So this thing is still moving forward, right? And I still have my system. I still have my closed loop. I'm expelling energy, and now look what happens. Even though, boom, right, this whole system didn't stop. I'm still going out of my frame of reference. And it just happens to be the whole system. See, this is the problem with the idea of a closed loop, right? This is a closed loop right here. It's a closed loop. The gases are not expanding out of here. And by the time that they hit the back here, so let's say the gases do stop this. Let's just say it's the back and forth, ding-a-ding-a-ding, right? So this is going back and forth, right? By the time the gases get back here, I can have already changed my aspect. So I'm going to just change it a little bit so that each time when I run it, I'm not hitting in the same spot. So the gases can't go in the same position. You see what I'm saying? So they're going this way and just bouncing around. They haven't even hit the back wall yet. And I've placed 3 or 4 different things. So now it's just filling up with smoke. Right? Unless you're saying the smoke is going to drive us out of here. No, it's just going to fill this thing up and kill us all. Not a great way to go. This is not how you fly in space. But it's a common sense physics answer to propulsion. I mean, come on, people, look. I get it. Like the idea that flying around in space like the Jetsons is just lunacy. But this is physics. You can't BS your way through it. Like, this isn't shaking a ball back and forth, right? This is the concept. So if you can mimic this same force without a rocket, right, to get this asymmetrical to this, and consider these as 2 separate systems instead of one closed system, whenever I fire this rocket, I open up that system. I hit this, it is now an open system. Even though nothing escapes, I'm not losing any mass. Well, no, actually, when I don't know how that works. When you convert the fuel to smoke, I mean, you're changing the everything around. You know what I mean? So things are the center of mass has completely changed. You're turning what was condensed matter into just a bunch of nothing. So you're never going to stop this platform moving. You can't. And as long as you have a thrust that is, how do I describe it? Everybody's used to thinking of an equal and opposite reaction. So So if I throw it into this is going to go directly back. It has to. Even if it hits the side, the other side is going to bounce back. That's not propulsion. That's you're just shaking back and forth, and you can do that forever. You can spin it around, you can shake back and forth, you can do whatever you want. That's not unbalancing the load. You have to have asymmetrical force like this. That's it. You're done. Now it is no longer ever going to be in its center of mass again. We run this thing out and goodbye. It's just gone. So it's just a different application of force. So that's basically what closed loop pulse propulsion is trying to get across. Is you just need to look at inertia a little different. On Earth, this could never work. Not because it can't, it could, but we have friction and things that just make this counterintuitive. But out in space, where there is no gravity, you don't have the same issues. You know, I mean, oh yeah, see that's even broke. Oh, but it's got a thruster. We can see it ourselves. Oh well. Anyway, but you get the idea. So anyway, that's the essence of closed loop pulse propulsion. I mean, I know it's a difficult concept to believe, but it's not a remotely difficult concept to understand. So, and I mean, I have countless videos you can watch on how to do it. I mean, from space balls to just the craziest, like this one here. Just yeah, how do I even run this one? You start here. You gotta get this one. Uh, just run one. Okay, so I hit this, boom. Let's stop it. Okay, boom. We stop everything moving. Boom, frozen. Okay, now it's not. Well, it is still moving because. Oh, let's get it. All those balls and they got a bunch of compression, so it's free to all those springs and everything. See, you can't even stop this one. That's what's funny about it. Once you get it moving, it's not. Look, I just watch, just let it go. Right? It's because the speed is at 9,000, but it's never going to stop. You can't stop it. Let's see if we can. I mean, it's just frustrating because you just can't. Once it starts moving, it's just done. I don't get why people don't see it. It surprises me. Okay, so we're stopped. Everything's stopped. I mean, it's really not. You let this, yeah, see what I mean? It's not going to stop. But then you just run this thing and it bangs the hell out of it. Dun, 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 and just starts shaking these things. And that's it. And then these balls start whacking into it. See what I mean? Then you just woo, speed it up. Like you're never putting that thing back into position. It's done. This is not rocket. It is rocket. This is rocket science. So it's hard. I get it. But look, it's not spinning around and going. It's literally going in a straight line. And then once you just do whatever you want, you drive it. It's stupid. But this one does some crazy stuff. So this will do some crazy flipbacks and you know, this one's a fun one. Watch. This is going to do some nutty stuff now. Look at that. Yeah, tell me you can't move out of your center of mass. You can't. You can't. You're absolutely correct. You cannot move out of your center of mass. The problem is it if you're constantly rearranging your center of mass and the equation that governs the center of mass can't put you back, well, what happens? This. To me, that's moving out of your set. That's not. I'm not driving the spaceship well, but clearly I can move around. Shake it up a little bit, let it go. Boom. Now what happens? It seems like you put energy in, it's got to go. That's the law of conservation of energy and the conservation of momentum. That's the immutable laws of the universe. What you're seeing here, this isn't magic. This isn't, you know, breaking any laws of physics. This is a simple math program. This program isn't broken. It works fine. You know how I know it works fine? Because I knew this would do this. I didn't build this by, well, not this particular idea, but I got bunches of them. I mean, some of them are absolutely terrible. Like this one, I mean, how does this even work? 4, 5, and 6. Boom. First sum of 4. There it is. Let's see. Yeah, it's already gone. It's already out of it's just done. It's already done. You know what I'm saying? It's already gone. There's no putting that back. Well, once this thing starts moving, because that's pretty heavy. It's not really moving. You know what? Let's get rid of that because I think that's too heavy. Okay. Too heavy of a payload. Let's slow everything down, freeze velocities, get rid of this. Yeah, make sure this. Like I said, I have so many of them, I actually forget what they do. 4, 5, and 6. Pretty sure we're out of our. Maybe. Wait, how'd that one get on that side? Yeah, I don't think this is going to go anywhere. This is probably just one's a bust. I forget. I work on so many of them. Oh, no, there it goes. Knocked it right out. Yeah, you just got to knock them out. Asymmetrical force. Yep, there it goes. Boop, 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 boop. Yeah, I knew this one worked. Oh, yeah, I got all these little guys up here. I don't know what this one's doing. See? And they're just not hard. Like, that's probably a dot. Just the way it looks. Oh, here's a guy. No, I guess it works. Here's his buddy. Floating around out in space. It's funny. Anyway, but you get the idea. So, yeah, the point is that inertial propulsion is real. I mean, it's just unbalancing the load. And if you're just looking for the equal and opposite reaction, then yeah, you're right. If you go straight forward and straight back, you're never going to get out of your position, and you can spin around and do all kinds of crazy stuff. But that's not breaking symmetry. You have to break the symmetry, and that's what when you shake this thing all around, right? I mean, it's breaking the symmetry and forcing a rearrangement of the system. See, so now it's not the same system it was. It can't be. Everything's different. It's striking things in a different area. You have to account for all the forces that you put into this system. I mean, that's just how it works. All of those squiggly lines and stuff, they matter. They do. You have to account for them. And just to say that your opinion matters more than the math, well, this kind of proves that the math means more than opinion. So, or you can say that the people that wrote this program have no idea how to make a physics program, but they pretty much do. That's their job is to work with stuff that has to do with physics. So, explain to them why this is doing this, which it should not be doing. Thank you.